Designing a circuit using electronic design automation like EasyEDA tool is one of the most demanding skill in ESDM industry. It requires true efforts and patience to learn the fundamentals of PCB designing activity. The schematic design work is the most important step involved in a new product development for ESDM industry. In this video, I'm going to give you a detailed explanation about how to design and develop a schematic related to your circuit that we discussed in previous video. Hello everyone, I'm Vaibhav Sugandhi, passionate PCB designer and technology startup founder. Welcome back to our course on PCB designing for absolute beginners 2022. I believe you have watched our previous video in this course. If not, click on the I button here and do watch that video before this one. If you like our educational content, then help us to reach more people by sharing this content with your friends and colleagues. There is one important note here. At this point of time, you must be very much aware of how to use a datasheet and how to use a block diagrams. If you have idea about black box analysis and white box analysis and also the datasheet analysis, then you must be having an idea of schematic design and the circuit diagram at this point of time. If you are not aware of circuit diagram by using a datasheet analysis, then do complete that activity before jumping into this particular tutorial. I hope you are able to see my screen right now, and I am in the EasyEDA tool, which I already explained you how to install this one in the previous tutorial, and I'm very sure you have learned this one and you have created your account. Make sure that you have logged in your account here by clicking on the sign in option if you have created your account and you have created your account in EasyEDA platform. Now you also need to make sure that you are in a standard mode, not in a simulation mode. Why? Because if you are in the simulation mode, the options visible to you is going to be different than the video that I'm recording today. So that's why make sure that you are in a standard mode. Now we can see that there is a project directory here and we need to create a project to understand how to design your schematic. I'm going to give you a detailed explanation about creating a small project that is all about converting 12-volt DC into 5-volt DC. Let us assume that you have got a 12-volt DC adapter and you want a 5-volt DC for your project activity. Then what kind of a circuit you need to design? Based on that, we are going to create a project today. Of course, it is interlinked with the video that I have uploaded previously, which is related to 7805 datasheet analysis. I believe that you have understood every concept with respect to datasheet analysis, and also you have understood what kind of a circuit diagram is required for 7805 circuit. Now I'm going to create a project by clicking on File and going to the New and clicking on the project option. A small pop-up window will appear in front of you. First thing, you make sure that which folder you want to use. In my case, I have 3 folders because I had my personal account as well as my previous company account and also my current company account. However, I'm going with my personal account at this point of time. In your case, probably it is only personal account. Then you need to give a proper title to your project. As of now, my project title is plus 5-volt DC power supply. And then a description is optional. If you are interested, you can. Otherwise, you can skip that part as well. And a new interface appear in front of you. You can see that the project is created and you can see a schematic window. In fact, it is a schematic sheet where you are going to design your circuit diagram. And also you can see that the folder is created under your directory, which is all about Vaibhav Sugandhi in my case. And also there is a sheet created inside that. First thing first, I am very good with respect to keeping my data in a proper condition, in a proper directories. So I am always concerned about the name and the kind of saving pattern with respect to the resources. So I am going to change the sheet name with a schematic because it is all about schematic. So I'll change it to schematic, and then we have to change the title in this schematic sheet. I'll double click on that and I'm going to change the name of the sheet. That is all about plus 5-volt DC power supply. After that, if you have a company name, you can give that name as well. In my case, now it is a linked frequency. and my name is already updated by default because I have logged in with respect to this particular account. Now this is an area where we are going to create our circuit. Make sure that your circuit is always within this particular margin, which is all about the sheet margin for the schematic. And I'll give you a quick introduction about the tools available for your schematic design activity. First of all, this is the project manager or maybe the project detailed directory where you are saving all the files and accessing them as per the requirement. And you can see that there is something called a design manager. Design manager is one place where you will get to know is there any ERC error with respect to your circuit or the schematic that you are developing. And of course, it will also give you the number of components being used in the circuit and number of nets being used in the circuit as well. Nets is nothing but the connection between one part of the component to the another part of the another component. And you can see that there is something called common library. This commonly used library, which is all about the basic library and a local library, where you will get the most of the basic electronic component. However, a special ICs or maybe the special component that you want to use in your circuit might not be available in this local library. On that time, you have to click on the global library, which looks like this, and you will access the larger library that ever you can imagine. Because this place is something like a user contribution or community driven contribution, where my designed library, if I have designed any library which you can access sitting in your computer, sitting in your home. Of course, your circuit is being private until and unless you are sharing it with the open community, but the component library that you are designing is open for everyone. So this is a global library where you can search for the special components that you are intent to use, which is not available in local library. But again, in the previous video, I have said one more thing. 95% of the components are available on this global library or in the local library. But the remaining 5%, it is all about your responsibility to redesign them as per your requirement. Of course, in the coming tutorial, I'm going to cover about how to design your own library as well. So this is all about the global library. And then we will be having so many options at the top side which are not so important to discuss at this point of time, because as per the time, as per the experience, you will learn how to use those tools and techniques. However, the most important part of the entire schematic design activity is all about the wiring tools. You can see that there is a wire available which is having a W key as a shortcut for accessing that particular tool. And then we will be having a bus bar, which again I am not going to discuss in this tutorial, but you must remember that one. And we will be having a bus entry and node connection net flag, which is very important, and this net label or net flag, which is very important when you are creating a connectivity between one point of the component to another point of the component without drawing the wire. But still, if you want to connect it, you can use the net information or maybe net label. Then we will be having a ground label, and also the different variety of ground labels are available here just for the differentiation between analog and digital ground. And then we have a port label which is required for communication or a connection between one sheet of design to the another sheet of design, which is very common factor when it comes to hierarchical design. Of course, we are not diving deep into hierarchical design and the complex jargons with respect to PCB designing, so we are not going to bother about it. We will be having a VCC and plus 5 volt net flag also, which is essential for indicating the VCC or plus 5 volt or even any 3.3 volt or a 12 volt as per the requirement. Then we will be having a no connection flag, which is essential for indicating to avoid the ERC error when it comes to a non-used GPIO in any microcontroller or microprocessor when we are designing something related to that one. And of course, we are having a voltage probe for monitoring the voltage in simulation mode. Of course, in standard mode, we are not concerned about using a voltage probe and all. Then we will be having a pin and grouping the objects or grouping the circuit in one particular module and all. Of course, we are not concerned about these two things. Other than these things, we will be having tools related to drawing activity. If you want to draw a rectangular box for categorizing your circuit, then we will be having that option. If you want to draw a circle, then we will be having option. If you want to write some specific text related to your design activity, then we will be having that option in the drawing toolbar. So these are the two important toolbar which you are using more often than any other things in this entire circuit. Make sure that you hit a Ctrl S again and again when you are designing a circuit, because this software is not having an autosave option. And the more important thing is you need to have an active internet connectivity when you are using this particular software. So make sure that your computer is connected to internet all the time. Now let me jump into discussing about how to design plus 12 volt DC into plus 5 volt DC power supply design. Of course, I'm not driving into a very complex circuit so that you will understand the basic one and you will understand the procedure more important than the circuit diagram, because circuit diagram is not constant. You are going to design multiple circuits in coming days. However, the procedure remains same whenever you go for the schematic design activity. So that's why first thing first, we need to understand how we get the 12 volt to the PCB. First thing, we will be having a two option here. First option is all about using a DC jack, which is very common, which is a adapter cable which is available directly in the market. We can use a DC jack and we can use a 2-pin connector. 2-pin connector or a terminal head is one more way to get the 12 volt to the PCB. I will go with the two of them. I will keep both the options so that my customer or maybe this product, whenever I am using, if I am having a 12 volt DC jack available to me, I'll use the DC jack directly. Or if I'm using a SMPS board or a PCB externally, then I'm going to use the wires to connect the 12 volt input to this particular board. So we are going to scroll a little bit down here and you can see that there is an option for connector TH. TH indicates through hole. SMD indicates, or SOC, those indicates the SMD component. However, right now TH is all about through hole, and in India we are using a 5.08 pitch available with the connectors. We are not going to use a 5 mm directly. There is a very small difference between both of them, which is a 0.08 mm, but that is going to create a lot of difference when you are manufacturing the PCB in mass quantity. So that's why make sure that you are using a 5.08 pitch connector only. 2-pin connector because it's just a 12 volt and a ground pin. There is no other voltage. So I'll place this component like this. Just clicking on the component, you will get the cursor attached to that component. Rotate it if you want to rotate it by using a space key on your keyboard, and by rotating you will place it in a right direction like this. Right now whatever I'm placing in front of my screen. And then we need a DC jack. So I'll scroll a little bit down. If you scroll a little bit upside, you can see that there is a DC jack available to us. Again, in this we have a different footprint available. I go with the first footprint by default because now I'm not diving deep into footprint activity and all right now. So I'll go with the by default footprint and I'll place it next to this particular connector. Thereafter, when you hit a escape key, your cursor will be detached from that particular component so that you can bring the next component in the system. Now next component is all about the input capacitor. So we have a multiple types of capacitor in the industry. First one is ceramic capacitor, second one is electrolytic capacitor, third one is tantalum capacitor. However, right now we are using an electrolytic capacitor. I believe that you know the difference between electrolytic and ceramic capacitor. So I'm going to use this electrolytic capacitor again with a through hole technology and the diameter of 6.3. Why? Because the 22 microfarad or a 33 microfarad capacitor usually come with a 6.3 diameter. If you are not sure how it is 6.3 diameter, 6.3 mm diameter, then do refer the data sheet of 33 microfarad electrolytic capacitor. That will give you the idea what is the exact footprint of that particular capacitor. There you will get to know the pitch also. Pitch is 2.5 mm right now. So you can check with the data sheet and come up with the idea whether we need to go with a 6.3 mm diameter or the 8 mm diameter. Whichever is suitable, you can go with that. Right now, I'll go with the 6.3 mm diameter and pitch is being 2.5 mm. F indicates the pitch between one pin of the component to the another pin of the component. So I'll select that footprint and I'll be using that particular capacitor. Now I'll placing this capacitor somewhere here and I will just hit the escape key on my keyboard, where I have a freedom to get the new component. Thereafter, we need a 7805 regulator. Of course, in a local library, we will be having a 7805 regulator, which is available here. And of course, TO220 package indicates it's a through-hole technology. As I already discussed in previous video with respect to datasheet analysis, there we got a multiple versions of 7805. One is TO220 package, another one is SOT89 package, and there are so many other packages are also available. Wherein the TO220 indicates it's a through-hole technology. SOT indicates it's a surface mount technology. Of course, in this video, I am more focusing on through-hole technology. That's why I'm going to select the TO220 package. So I'm going to bring that particular component here, just next after to that particular capacitor, and we are done with placing the 7805. Now the next important component is output capacitor. Again, I can copy paste this electrolytic capacitor for sake of now, and I will change the value later. Of course, I have not changed the value of input capacitor, so output capacitor also I can change at the same time. Then we need output connector. Of course, we have another option right now. We can go with the RMC connector, we can go with the normal header connectors, or we can go with the connectors of 5.08 pitch. Whichever is comfortable to you, you can go ahead with that. Of course, as per my knowledge, as per my industry experience, I believe that we need to go with 2-pin header connector, or maybe the 2-pin connector, which is essential for your input and output as well. So it will look like a symmetric design, right? Input side you will be having a green color connector, and output side if you are using a RMC connector or something. Of course, nothing wrong in that, but I don't prefer to go with that kind of a system design at this point of time. So I'll be using a green color connector here, which is again a replica of input connector, and this is all about our components. If you want to add a one indicator LED, which is just indicating whether the 7805 is working or not, then of course you can add it by using a resistor and one LED. I'll show you how to add that one as well. Here we have a resistor, and RXCL underscore or RXCL 0.3 is indication of through-hole technology. The SMD technology or SMD components are indicated by 0603, 0201, or maybe 0402. So we are not going to jump into SMD as I already said, so I'm going to use RXCL 0.3. So I'm going to use this resistor next to capacitor, and one LED is required for us. So again, I'm going to use a 3 mm LED, not a SMD, a through-hole one. Through-hole 3 mm red color LED. So that red color indicates the power of this particular circuit. So this is how our components are being collected from the local library. Of course, this is a very simple circuit. That's why we don't need any component from the global library. But in some cases, if we want a global library component, we can use that one. So now what we need to do is we need to arrange these components in a proper way, and we need to connect them as per the requirement. Let me do it and show it to you. Here you can see that I have connected or I have placed these components in a proper way such that we can make it easy for ourselves to connect them as per the requirement. Of course, I believe that you understand what is the circuit diagram for this particular example. So I'm going to just start with a circuit connection, not explaining anything related to circuit diagram, because that is a basic fundamental learning that you must have before jumping into this tutorial. Now you can see that the connector is placed here, and the DC jack is placed here, and the connector is placed here, and wherever you can see the component possibly adjusted in a smaller area, we have done that. Now the next important part is connecting them as per the circuit diagram. First of all, I'll use the ground symbol to connect the first pin of this connector to the ground, like this. Of course, we can use a W key, which is a key for wire tool. Otherwise, you can click on this particular icon here and start with wiring. And by using a left key or left click on your mouse, you can start the routing. And whenever you complete the connection from one point to another point, hit the right key on your mouse. That is how you are going to create a circuit diagram by using wire tool. So now I'll show you how to connect this one from this point to this point. It's as simple as like that. And after that, you can see that the DC jack is also need to be connected here, and the capacitor need to be connected here. These 2 points need to be connected to the ground point, and of course the capacitor negative point should be connected to this one, and also this one should be connected to this point. And then you can see that the output of this 7805 need to be connected to output capacitor, and then followed by a resistor, and then we will be having a connector for output voltage. You can see that the bottom side we will be connecting to the ground, and this one looks like little outside the boundary, however that is okay for us, and the LED connection with the resistor, and this point should be connected to the ground of the entire circuit. Now you can see that this particular circuit is not yet connected with a ground symbol, so I'll use a ground symbol here and I'll be connecting it to this point. Now this is all about the circuit where I'm going to change or maybe disable the name of this LED, and I'll placing the indicator or a designator of that LED somewhere here, and then I'll place the name of this component here and this one here. Okay, now you can see that this is how our circuit looks like. The most important thing is changing the value of the component is also important. So I'm going to change the input capacitor ka value, which is all about 33 microfarad. A small u on your keyboard is indication of micro. Capital F is a farad, indication of capacitor as always. And then along with this 33 microfarad, we also need to mention the voltage of this particular component. So by adding a forward slash, we can start writing the voltage. In this case, I would like to go with a 25 volt. Why? Because the input voltage of this capacitor is 12 volt. And always by practice, we go with the double the input voltage or double the voltage being used on that particular component. So if we are having a 12 volt ka input on this particular capacitor, we can go with 24 volt voltage capacitor. Of course, 24 volt is not a standard in industry. That's why I'm using a 25 volt capacitor. Then at the output side, we will be having a 5 volt DC coming out from this particular regulator IC, which is 7805. So that's why I'm going to use 33 microfarad capacitor with 16 volt, because 10 volt is not available in industry in the larger scale. Probably it is available, but 16 volt is more common than the 10 volt. That's why I'm going with the 16 volt. You can see that the name of that particular component is overlapped with the second component, the next resistor. So I'm just adjusting it to back to the normal. Now you can see that the output resistor, the load resistor for this LED is having a 1 kilo ohm resistance. Of course, you can change that value by maybe a 560 ohm, 1 kilo ohm or 1.2 kilo ohm based on the requirement. Of course, we can write it by using a international standard method, that is 1K2 is indication of 1.2 kilo ohm. So I'm going with a 1.2 kilo ohm just by practice. There is no specific definition for that. Otherwise we can go with a 1 kilo ohm as well. And then we will be having an output connector, which is absolutely fine. And this is all about your circuit. Okay, so this is all about your circuit. Now you are done with the schematic design activity. But of course we cannot leave this circuit like this, which is not so professional, right? It is not about just a knowledge that you can create a circuit. Also, you must have a discipline to make it as a professional design circuit. So how we can do it, how we can make it a professional design circuit? By adding a one title here. By clicking on this T icon here, which is all about a text icon, I'll be able to place a text here. So once I double click on that, you can change the name of that text or the content of that text, which is all about plus 5 volt DC power supply. And we can increase the size of the font by looking at this. When we select the component, we can see some properties here which we are going to change now. I'm going to change it to 12, and I'm going to change the color of the text to black, so it looks a little classy to me. And then I'm very interested to add a border to this particular circuit. When you are designing a multiple circuit, you must categorize them by using a border. How to add that border? There is a rectangular option here, which is also a shortcut key for that is a yes. But of course, I'm using a rectangular box or rectangular icon directly from the drawing window or drawing drop down. So now I'll draw that rectangular just around this particular circuit. And I'll hit a escape key coming out of from that rectangular option, and I'll select that rectangular box, and I will change the stroke style to dashed one. So this will give you a imaginary line kind of a effect which will indicate that this particular circuit is one module. And if you are having a circuit which is having a multiple modules, this particular information or this particular drawing border is much more better than anything else. So once we are done with this, I will place my entire circuit you can see that I'll hover my cursor on the entire circuit and I will drag this particular circuit at the corner of the schematic sheet, right? Because there is a lot of area which is unused in this schematic. So I'll be placing it somewhere here, and I'll be selecting the entire margin or entire the border of this schematic sheet, and I'm going to change the width and height. There is no specific formula for changing the width and height, so I'm going to use a trial and error method. So now I'm going to use somewhere around 600, just giving a try. Okay, 600 is still larger one, so I'll go with a 500. Probably good one, but still I'll go with no, I should go with a 500, because the bottom side, whatever the indicators are here, whatever the information is written here, I don't want to miss that information outside the margin. So I'll keep it as it is. And the bottom side, height wise, I'm going to adjust it as 400 probably. Wonderful, 400 is exactly fitting to that particular requirement. Now I'm going to drag my circuit once again, fit to the circuit somewhere middle like this. It looks middle to me. And we are done. Now I'm going to change the origin of this particular sheet, or maybe the canvas, to the origin of this particular sheet. So how do we do that? We can hit a home key on your keyboard and do that also. Otherwise you can go with the format option, no, place option, and set canvas origin. In the set canvas origin, you can see that the mouse location is one way to set the canvas origin, or by using the coordinates. But right now I would like to go with the mouse location. So once you click on that, your mouse is having the ability to set the canvas origin to this particular location. When you click on that, you can see that your circuit is being organized with the proper position. This is how you should create a schematic diagram professionally. It's not just about the circuit diagram. It's not just about the connecting one component to another component. It is also about making it looking professional. That is where the skills comes into the picture, right? And next important step is all about understanding the footprint required for these components. Say for example, right now while selecting only, I have selected the proper footprint according to my knowledge. But there is a probability that I have made a mistake, right? So I'm going to cross verify whether the footprint used for this particular component is right one or wrong one. By selecting that component, you can see that there is an option for custom properties. In that custom properties, you can see that there is something called a footprint. When you click on that particular option, you can see a new pop-up window appears in front of you, where you can see the footprint visually. Also, you can click on the pad size and verify whether the pitch between one component to another component is 5.08 mm or other than that. If it is 5.08 mm, wonderful, that is the right one. And the next component is all about DC jack. We can do this activity in one shot, or we can come back to schematic, select the component, click on the footprint activity and go back to this one. This is one procedure. Another procedure, you can see that all the components used in your schematic is visible to you here. You can just cross verify all the component in one go. Now I am very sure that this particular component is the right one. The footprint whatever used in here is the right one, because as per my knowledge it is right one. But for you, you can refer the datasheet of a DC jack. Okay, refer the datasheet of a DC jack and try cross verifying all the dimensions of this particular component with the datasheet. Then you will get to know that whether this particular footprint is a right one or not. If it is not right one, then go and change it by using a global library or local library. But I believe that in this particular case, this is the right one. Next component is all about the capacitor, 33 microfarad 25 volt capacitor, which is having a 6.3 diameter and a pitch is 2.5 mm. But now I believe that I have made a mistake here. Okay, the 16 volt capacitor is having a 6.3 volt diameter, that is the right one. Pitch is also 2.4 mm, 2.5 mm, that is also right one. But for the 25 volt, it is not possible to have the same diameter and the same pitch, right? So now I'm going to change the footprint of this particular component. This is one example how to change the footprint as well. I'm going to change it with a different value, different diameter. So probably 8 mm diameter. You can see that capacitor with 8 mm diameter and 10.5 mm height, which is SMD component, by the way. How do you know whether it is a SMD component and a through hole component? You can see here when you click on that particular component footprint, you can see the red color pad here. I hope you are able to see this one. So this red color pad indicates it's a surface mount device. I hope you have watched our previous video, which is related to SMT and THT technology. If it is not having any drill hole, then obviously it is a SMT component. If it is having a drill hole, then it is a through hole component. In this example, we are focusing on THT. That's why I'm going to select the other one, which is having a drill hole like this. Okay, so if we are having a drill hole like this, then we are going to select that particular component as a footprint. So I'll double click on that, and you can see that the footprint is assigned to that particular component. You need not to change your component in the schematic activity, just change the footprint in the schematic library with respect to footprint wizard. So now I'm going to cross verify with respect to my 7805 regulator whether the footprint is TO220 package or not. I believe looking at the 2.54 mm pitch between one component, one pin to another pin, it is TO220 package. And by looking at the footprint activity, with my experience, I believe that this is a it's a TO220 package. Very easy to recognize those things. When you spend a good amount of time in industry, good amount of effort and time with respect to learning, it is quite easy to identify the component by just visual inspection. Now I think TO220 package is ready with a 7805. Then when it comes to resistor, again it is a through hole technology and 0.1 inch bending between one point to another point, which is a pitch of that particular resistor. Absolutely right one. And we are going to verify the LED. Again, this LED is having a 2.54 mm pitch between one component to another component, and it is a 5 mm LED, which is absolutely correct. And as per my knowledge, this is the right footprint to use. This is how you need to verify the footprint with respect to every component you have used in your schematic. These are the important steps related to designing your schematic. Make sure that you follow all these steps and complete them, because the next tutorial focuses on the PCB layout design activity. It is not going to tell you anything related to footprint. If you have selected a wrong footprint in this particular activity, next procedure is going to be mess with you. So make sure that you follow all the procedure that we have discussed in this particular video and complete your schematic design activity. Congratulations, you are completed with designing your first schematic in EasyEDA tool. Now it is time for review activity. You are done with your own review with respect to component library and component footprint and all those things. But if you wish me to review your circuit, you can send me your circuit diagram or in the PDF format, and I'm going to review that particular thing for you. How to do that? I will share it with you. Now, once you are done with your schematic activity, make sure that you save the file by hitting a Ctrl S. Then go to the file section, then go to export option, click on the PDF, and you will be having a multiple option here. Make sure that it is in the PDF format, and of course you are having a 1x width which is essential for me to review your circuit. It is better to use a 1x instead of using a 2x or 3x. It is better to go with 1x. And then you make sure that you are using a local engine, and then you are using a merge sheet, because you are not using a multiple sheet design in your activity, but again make sure that you are having a merge sheet here. And then click on the export option. A new pop-up window will appear to you. One important thing you must remember is this pop-up window is not having an extension by default. The .pdf extension you have to give by yourself. Otherwise, nobody is able to open this file in their computer. Now, I'm going to change the name of this particular file as schematic _+5 volt DC power supply .pdf. You need to add that extension .pdf. Once you are done with that, it will be saved on your desktop. Now you can see that on my desktop I'll be having this schematic of this particular PDF. I'll double click on that, and you can see that the schematic is visible in front of you right now. So this is how your schematic looks like. This is the professional way of designing a schematic and exporting it into the form of PDF and sharing it with a review committee. Now if you want me to review your schematic and give you feedback, please send this particular PDF in our comment section below. You can upload this particular PDF in our Google Drive and share that particular link in our comment section below. I'm very happy to review your schematic and give you feedback for your learning purpose. I hope you have learned something new in this particular video. If you have any questions related to schematic design activity, feel free to ask me in comment section below. Of course, I'm going to review your circuit if you are sharing with me in a comment section. For such more informative educational content, consider subscribing to our channel Linked Frequency. Tune yourself to make a difference.